Welcome to today's stream, and we're going to kick off today's stream with another Formosa problem where we're going to try and work out the answer to this question. So I'm going to give you should be getting good at these, should know the integral of these. They're very similar questions. So we're going to start off with about 3 minutes for this question, see how you get on. Right, here we go. So, first thing we've got to do is, in its first 10 seconds of flight, it rises to a height of 75 natural log of 5. So what that means is the integral from 0 to 10 of a over 2t plus 5 dt must equal to 75 natural log of 5. So let's integrate this. Now, it's going to be something to do with natural log of 2t plus 5. Modulus. And when we integrate this 2t plus 5 and we've got the a, we must get an a coming out, and then we're going to have to divide by 2 to get the a. Okay, because you're going to get the 2 times by 2, so we need to divide by 2 to undo that to get a when we differentiate this. So we're going to get that, and we're going to go between 0 and 10, and that's going to equal to 75 natural log of 5. So let's just put the limits in. So we get a over 2, and that's just going to be of everything. So we might as well just take that as a factor. So we get 2 times 10 natural log of 25 when you add the 5 to it. And we're going to minus from that the natural log of 5, because 0 times 2 is 0 plus 5 natural log of 5 equals 75 natural log of 5. And a over 2 natural log. Now, when you're taking them away, you're going to do 25 divided by 5 equals 75 natural log of 5. And you can just see that's the natural log of 5. So therefore, a over 2 must equal 75. So a must equal 150. So we found that, and we want to find the total height it would reach in 22 seconds. So what we can do is we can jump straight to this stage and put 22 as our top limit. So we've now got 150 over 2 natural log of 2t plus 5 between 22 and 0. Put that in, so we've got 75 natural log 44 plus 5 is 49 minus 75 natural log of 5. So that's equal to 75 natural log of 49 over 5. And it doesn't say we need this in exact form. This is an exact form. If you wanted to calculate that, we get 171.172 that many places. Right, next question. Question 2. Have a look. Work out how much time you can start it. I'll see how much time. It's not very tricky if you can see it. I'm going to give you 2 minutes, believe it or not, for this question. It looks like it might be harder, but if you see it, it's definitely not going to be longer than 2 minutes. Right, that might have been a little bit tight, but if you can see the quick way of doing it, then it wouldn't have taken you very long. So it's all a question how well you know your formulae. Now, if we take the left-hand side of A, so that's equal to 1 minus cos 4 theta. Well, cos 4 theta, that's a cos 2 theta problem. And cos of 4 theta is going to be equal to, we want to get into sine squared, so let's use the sine squared version of the formula. That's 1 minus 2 sine squared. Now, because it's 4 theta, we want to halve the angle. That'll get us to 2 theta. Okay? And I get 1 minus 1 is 0. Minus and minus gives me a plus. So this is just 2 sine squared 2 theta. And it's as straightforward as that for part A. Part B. Again, we're going to take the left-hand side. And we obviously want to try and get this into cos. So we've got to try and think of how we use the double angle formula again. Now, if you take 3 out as a factor, you get 1 minus 2 sine squared theta over 2, which is essentially the reverse of this. So we're going to end up doubling the angle to go back to cos theta. So it's just equal to 3 cos theta, because double of theta over 2 is just cos theta. So you can see why I only gave you 2 minutes to do that question. If you know your formula off by heart, then it would have been doable. If you don't, there's a bit more of a struggle. Right, next question. Okay, what we're doing in this question, for those of you not familiar with this course, is we're looking at trying to replace, in this case, the ux is equal to 2x plus 3. Write f of x in terms of u. Okay, and it shouldn't take you very long once you've worked out what to do. I'll give you an example. So f of x will be u to the 4 in this case. So I'm just going to give you 30 seconds to try and do the others. It shouldn't take you longer than that. Okay, time's up there. So we got f, as I said in part A, we got f of x will just equal u to the 4 because u of x equals 2x plus 3, so this is going to be u to the 4. Part B, f of x, again we got u is equal to 2x plus 3 squared, and we want this to the 4, so it's just going to be u squared. C, f of x, again we've got u is equal to 2x plus 4. Now we've got 2x plus 3. So therefore, we're going to have to take away 1 from this to get that. So you've got u minus 1 to the 4. And for part D, we've got f of x equals, we've got again 2x plus 3, and this time we've got u equals x plus 1. So what we have to do is, if we times this by 2 and add 1, we'll get 2x plus 3. So we've got 2u plus 1 to the power of 4. For that one. So that's how we do that question. So let's move swiftly on to the next question. So a little proof by contradiction, not a terribly hard one. So I'm going to give you a couple of minutes to have a go at this one. Right, so here we go. So the first thing we do, we know that 2n plus 1 is odd. I need to write the word odd there. So we're going to assume that 2n plus 1 squared is even. Now 2n plus 1 all squared is equal to 4n squared plus 4n plus 1. So if this is even, this implies that 4n squared plus 4n must be odd. And we can take 2 out as a factor, 2n squared plus 2n. So is it actually is even? As it's a factor, as there is a factor of 2. Which is a contradiction. So hence we've proved that by contradiction the square of an odd number is always odd. Square of an odd number is always odd. Okay, so next question. 5. Here we go. We've got a related rates of change question. So I'm going to give you a bit longer to think about this one. My answer, not very long, but so we'll go for 3 minutes, see if you can pull it off in that. Right, so part A is quite straightforward. We've got a circular ink block, so therefore A is going to be equal to pi r squared. Now we want to show that dA by dt equals 2 pi r dr by dt. Now we're told the rate is increasing at a rate of 0.2 centimeters per second. So therefore dr by dt, the rate of change of the radius, is equal to 0.2. From this we can find dA by dr. And dA by dr, if we differentiate this, we get 2, with respect to r, we get 2 pi r. And we can then use the chain rule. And all these questions, we use the chain rule to find what we want. We want to find dA by dt. Now dA by dt must be equal to dA by dr times by dr by dt. So dA by dr is equal to 2 pi r. And that's going to be times by dr by dt. To do part B. I was probably jumping the gun a little bit. I was about to get on to what dr by dt is. So we know that dr by dt is equal to 0.2, then dA by dt must equal 2 pi r times 0.2, which is 1/5, so you get 2 pi r over 5. So we can find out what dA by dt when the radius is 4 centimeters. So r is 4 times 2 is 8 over pi. So 8 times pi over 5 centimeters squared per second. Right, next question. Question 6. Now, this one is just another question in the build-up to coming up with Maclaurins' theorem and Maclaurins' expansion. It's just putting down the groundwork to understanding what is going on here. And there's quite a lot of little derivatives to go on here, so I'll give you, although none of them are terribly difficult, so I'm going to give you 3 minutes to have a go at this. You might not spot C, but it's a question of whether you spot C or not. So I'll give you 3 minutes to have a go at this. Off you go. Right, so let's just differentiate these. So if we differentiate this first one, this a to the naught has no x's, so it just disappears. So we're just left, and we differentiate this, we're just left with a1. And then we're going to add to that, we're going to get 2 times a2 x, because then we take 1 off the power. And then we're going to get plus 3 times a3 x squared plus 4 times a4 x to the 4. Actually, we're just going to, sorry, there is no more because the function's just, sorry, I made a mistake there. It's not x to the 4, that's x to the 3. I've got to take 1 off the power. Sorry about that. Now, this will disappear when we differentiate again. So we're just left with 2a2 times, and then we differentiate the x, that will disappear. So we get 2a2 plus, now we're going to get 2 times this. Now I'm going to write this down as 2 times 3a3. It'll become clear why later. Take 1 off the power, left with x, and I'm going to get 3 times the 4 here, a4 x squared. Take 1 off that power. Differentiate this, will disappear, so therefore I'm just left with 2 times 3a3 plus, times this by 2, 2 times 3 times 4, a4x, and then differentiate this is all numbers, that will go, so I'm just left with 2 times 3 times 4, a4. So g of naught, so that, put naught in here, that's naught, that's naught, that's naught, so I'm just left with, so that's g dash, so let's go back to g of naught, g naught, 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 I'm left with a naught. G dash of naught, I'm left with a1. G double dash of naught, naught, naught here, I'm left with 2a2. G triple dash of naught, I'm left with a naught here, and I'm just left with 2 times 3a2. And here, for g to the 4 dash of naught, I'm left with 2 times 3 times 4, a4. So that was an a3 there, apologies. I made a mistake there again. It's 2 in 1 question. So for part C, find an expression in terms of n for g the n of naught. Now, hopefully what you've noticed here is I keep timesing by an extra number each time. We start off with 1a1, then 2a2, then 2 times 3a3, 2, 3, 4, a4. These are basically factorials. The next one will be 2 times 3 times 5. 4 times 5a5 if we were to go further, if we started up with higher powers. So that's just factorials. So effectively what we've got is n factorial, that number there, a to the n. And just that will explain why we've got factorials appearing in Maclaurin's expansion later. It's important to realise that naught factorial, so that's not a very good naught, this looks more like an a, naught factorial is equal to 1. And that 1 factorial is also equal to 1, and 2 factorial is equal to 2 times 1, and so on. And then 3 factorial is equal to 3 times 2 times 1. Worth remembering, naught factorial is defined to equal 1. That'll make that easier to understand why that's working for g naught still. So question 7. My link wasn't working there. Right, this is going to take a lot longer. There's a lot more to this problem, so we're going to give you 5 minutes for this last question. Nothing should be too tricky. You might need to use a bit of simultaneous equations early on, I should think. See how you get on with this. if you're at a loss where to start on this question, do realise you start off with a cubic, so it's ax cubed plus bx squared plus cx plus d. Try differentiating that and putting these in. Also realise that the curve itself goes through these points as well. So from these 2 points, you can set up 4 equations. One minute to go. Right, my students in the class have struggled with this one, so let's get through this and see how we get along. So we're going to use y is equal to ax cubed plus bx squared plus cx plus d. If we differentiate that, we get dy by dx will equal 3ax squared plus 2bx plus c. And the d becomes 0. So we know we have stationary points. So if we use the stationary points, in the dy by dx question, so we know that that's going to be 0. So we've got 0. Let's do the first one. Put the x value as 2. So 2 squared is 4. So times by 3 is 12a. 2 times 2 is 4b plus c. Put the other one in. Put the minus 2 in. So we get minus 2. So this is x equals 2. This was x equals minus 2. So put the minus 2 in. We get 4 times 3 is also 12a. But we're going to get minus 4b here plus c. And then if we use the y equals ax cubed plus bx squared plus x squared plus d, and put these values in because the graph goes through them. So we've got the y value is 0 here. So we've also got 0 is equal to 8a plus 4b plus 2c plus d. And then put the minus 2, 16 in. So we also get 16 equals minus 8a. What we've got plus 4b minus 2c plus d. So let's just number off our equations. So we'll call this one equation 1, and this equation 2, this equation 3, and this equation 4. You need, if you've got 4 unknowns, a, b, c, d, you need 4 equations to solve them. So what we're going to do is do equation 1 plus equation 2. And what you see is we get the b's will cancel. And you can see that we've got 0 equals 24a plus 2c. Now if over here we do 3 minus 4, equation 3 minus equation 4, we get minus 16 is equal to 16a. And then the b is going to cancel, the d is going to cancel, and we're going to get a plus 4c. So we can call this equation 5, and we can call this equation 6. And then what we can do is we can do 2 times this equation and then subtract that one. So 2 times 5 minus equation 6. So 2 times this minus that one give me 16 there. 2 times this 48 minus 16 is 32 for A. And then obviously the C's cancel. So that will imply that A will equal a half. And from that we can find C. So if A equals a half, we get 8. We get minus 24 divided by 6 gives me minus 6 for C. And actually, if we go back to this one and we do equation 1 minus equation 2, the A's will cancel, the C's will cancel. So we just get 8b equals 0. We can see that b equals 0. Straight off the bat there. If you do 1 minus equation 2. Okay, or we could substitute A and C back into these. It doesn't really matter how you do it. So if you do that, and then it's just a question of finding D. So you put all the values into here to find D, and we find that D will equal 8. So we've now got our expression. We've got y is equal to a half x cubed minus 6x plus 8. And what we can do is we can actually factorize that a bit, or we can draw it, because for the second part of the question, what we're going to do now is find the equation of the curve, and hence find the area bound of the curve and the x-axis. And it's always a good idea to draw a sketch. You could get your graphical calculator to help you with this. It doesn't say you can't. And you'll see that it touches at 2, and it crosses at minus 4. So those are going to be our limits, and that's going to be our area that we're doing here. Okay, you could, if it shows shows detailed reasoning, you can factorize this out. Okay, you can look for factors in this, and you can use your graphical calculator to help you cheat a little bit. Because if it touches at 2, then you know that x minus 2 squared is a factor. So take that out as a factor, and then that leaves you a half x plus 8 as the other factor. You're going to times by it, and then you can just show your factorization, then show how you got your graph if it says show detailed reasoning. If it doesn't, just get stuck in, put it into graph here, and admittedly you could put these 4 simultaneous equations straight into your calculator and get the answers out that way if it doesn't ask for detailed reasoning. Okay. So anyway, moving on, we can integrate this. Again, if it doesn't ask for show detailed reasoning, you can put the integral straight into your calculator as well. You can see that it doesn't cross in between, so you don't have to be worried about negative areas. But do remember, if this crosses between these 2 points, then what's above the axis counts as positive, and what's below the axis counts as negative and cancel out in your integral. And if it's asking for the area, you need to work them out individually. So we're going to integrate half x cubed minus 6x plus 8 dx. So that will give us 1/8 x to the 4 minus 3x squared plus 8x. That's between 2 and minus 4. And we could just shove that all in. 2 into here, 2 to the 4. That's going to give me 2, 4, 8, 16 over 8 is 2. 2 squared minus 12 here, plus 16 minus, we're going to get minus 4 in here. That will give us 32, minus 48, minus 32 at the end there. Okay, and just work that all out and you get 54 as your final answer. So the trick was to be careful and logical when you set out your simultaneous equations to make sure you don't make mistakes. And obviously the tricky bit was spotting that from 2 points you can set up 4 different equations. Okay, you got one from the y equation because these points go through or on the line, and another one because you've got stationary points, so you differentiate. So hopefully that will help you work out how to solve these sorts of problems in the future. Okay, our next stream will be starting next Monday. Okay, look forward to seeing you then.